for the third episode of season 4. I'm joined by my wonderful colleague, Caslin Fields, and we are going to be talking about deploying a chat app with Gemma on GKE. That's my understanding, and I'm going to learn the rest along with you. So, Caslin, what exactly are we going to be learning about today?
Yes. So I've been working for like months now on this AI chat app. Of course, everybody's trying to learn AI stuff, and one of the easiest ways is to build a chat app. But I wanted to do it with GKE. And so I have put my code into a private GitHub repo. Apologies, folks, if you wanted to follow along. This is still kind of a work in progress, so you're going to see the work in action. But I guess the gist of what it does is I have a Python chat application based on Gradio, which is a framework for building AI chat apps. It implements some really nice functionality for you, specifically for AI chat apps, and I didn't want to worry that much about the app itself, so I went with that. And then I also have Terraform to spin up my GKE cluster and all of the other resources that we're going to need. We're also going to store our chat history from our chat application in a Firestore database to make sure that it's persisted and you have a log of it, and we'll do some cool stuff with that. You'll see.
Seems like a reasonable architecture, like all the way down. Like a chat app is a good application because it lets you just get your mind wrapped around the concept. You can talk to it directly, realize how it's responding, nothing in the middle. And yeah, we're here to focus on the models, how it goes on GKE. So why not use a framework like Gradio, do some of the legwork for us? Sounds great. Excited to get into it.
And it'll build the container for our chat app using Cloud Build as well, so that I don't have to do any local builds.
Okay.
Cool. So could you share my screen? Because I don't have that.
Absolutely.
Thank you. All right. So here's what we're going to be working with today. Here's my private repo. And here I made myself a nice README. It's rather long. But
could you maybe zoom in?
Yes, I'll give it a shot. Let's see.
That is a detailed README too. Like it is better. I feel like I could fit 4 or 5 of my READMEs into that one. So that's fantastic.
If I'm gonna do a project, I'm gonna do it right.
Yep. And especially when it comes to GKE, like if Caslin looks familiar, you may have seen her on the GKE podcast that we have.
Kubernetes podcast. That was
Kubernetes
community focus, but GKE Essentials YouTube series.
I can't even count the amount of stuff that I learn and have to like poke around in the docs for every time I tune in. So it makes sense that you have more than enough stuff to put into a README like this.
Yeah. And mainly my issue was that I've been working on this slowly over several months. And so every time I come back to it, I don't remember anything that I've done. And so I needed to document it. And that turned into this giant README. So it's just enough README, really. Yeah. So it starts off with a screenshot. So you'll see this is the app that we are going to deploy. It has space for you to write your messages to the AI. It'll give its responses up here, and you can see the full chat log kind of in this window. And you can also actually choose which model you're interacting with. We'll have 2 options. We will have Gemma 2.9b IT, and we'll also have Gemini 1.5 Flash, I believe. I should say that more clearly here, but
and I'm somewhat familiar with Gemini 1.5 Flash, kind of our lighter weight, faster response model. Is the Gemma one that we're dealing with kind of the Flash counterpart?
Is there a Flash counterpart for Gemma 2 models?
I don't actually know. I've read more than I've done with the open model, so we can learn as we go.
The main thing that I see with the open models is that there's varying different sizes depending on what kind of environment you're working in. You might want to use a smaller size. The 9B is not the smallest one. There's a 2B, but it's on the smaller end. I think the largest maybe is a 27B.
Right. Okay.
So 27 billion parameters.
Fair enough.
Yeah. And so there's also all of these settings that you could use to adjust how the model responds to you. So that's what we're going to be deploying, and then it goes into the instructions for how to actually deploy it. There's several things that you need before you can get started. You're going to need a Hugging Face token because we are going to be deploying our Gemma model onto GKE. So we're going to be running it ourselves on the Kubernetes cluster where we are also running our AI chat application, which I'm excited about. I guess I'll talk more about that in a little bit. You'll also need a Google Cloud project. Of course, this is designed around Google Cloud stuff. We are on a Google Cloud channel, and that's what I use for work. So that's what we're going with. And as I mentioned, we're going to deploy all of our infrastructure using Terraform. So you'll need to have that installed, and you'll also need the gcloud CLI because there are several things that I set up with the CLI.
Sounds pretty straightforward. And yeah, I find that especially for people like myself who come more from like a background of like app dev rather than AI like heavy expertise or like deep knowledge or research, it makes this a lot more concrete when you can deploy it in a container and say, that is my model running. This is not some magical service that's running out there. It's just like I can put it in a container, I can see the outputs, I can see the resources it's using. It makes it a lot more kind of material for me. So I'm excited.
That's very true. Yeah, we'll take a look at some of those logs probably. Explore it a little bit. Cool. So shall we dive right into running the application and
yeah, why
start
not?
it off ourselves? It takes about 10 minutes for the Terraform to go, so we can go over the code while it's doing that. And then it takes about 5 minutes for the application itself to spin up. So there will be some wait time in here for us to discuss and explore.
Sounds good.
So I have a project already set up here. We're just on the dashboard page of it. I'm going to spin up a Cloud Shell. We can do all of this deployment in the Cloud Shell. If we want to mess around with the code, we'll probably open it up in the Cloud Shell editor, but we can worry about that a little bit later. How is this size, do you think? Should I zoom in a little bit more?
Zoom in a bit more, just because the console itself is a decent size. There we go. But yeah, the terminal is a bit small. Yeah, my first stop when I'm trying to just like demonstrate something and get the point across is the Cloud Shell, because so much is installed for you, including like as a Java dev, you have a decent Java runtime and you have SDK man. Lots of tooling to just get a whole bunch of concepts in your head before you need to save your work.
Yeah. So here's my Cloud Shell. I've been messing with it a little bit earlier today to make sure that I am all set up and ready to go. So if I do an ls to see what I have in here, I've got an examples folder, then I have my Caslin Gradio chat folder, and that's where our code is. And then we've got the README. Actually, I might need to pull back down the Gradio chat.
And while you're doing that, we have a question here.
Oh, yeah.
In the YouTube comments. What's the main difference between running a chatbot with GKE and Dialogflow CX? Okay, that's a good question. So Dialogflow CX is our kind of conversational agents. I believe it's a managed service. I haven't played with it myself a whole lot, but my experience with Dialogflow is that it is kind of like a drag and drop experience. Like it's supposed to abstract some of the aspects of like having to build it yourself away from what you're doing. Whereas GKE, you'd actually have control over the containers that are running the models, be able to see the output of each individual, service that's hitting it, what the responses are coming out as. So I would assume it would be a trade-off between like ease of access and control over what's actually being run on your services. If you have anything to add there, Caslin?
I have not looked into Dialogflow, but my understanding is similar, that that's a service that helps you get started a lot faster. That is not what GKE is for in this case. GKE is for helping you get started with Kubernetes faster, but Kubernetes itself is a platform for building platforms, and it's designed for enterprise use cases where often teams want a lot of control over not just the applications, but how those applications run on the underlying hardware. So this is going to be kind of a from scratch build of how you would run this.
Yeah, good question though, Callum. I feel like there's always more to explain on that concept, where a lot of the time when I'm working with cloud platforms, I am trying to trade off. I'm trying to give away as much control over my services as I don't need to make a meaningful decision on. So if I know that I don't need to do anything specific with like how my like the hardware I'm running on, then I don't need to go on Compute Engine. If I need specific like services to start up at certain times or to use like sidecar services, and I need control over how big those nodes are, then I'll be going up to GKE. And so I'll kind of like step backwards from the decisions I need to make into which compute platform I use. There's a whole bunch of good blog posts written about that. So good question. But yeah.
Absolutely. There's more that we will explore there as we go through, I'm sure. So I'm going to cd into the infra directory here. And in the infra directory, I have my main.tf file. For this, I only have a main.tf file. I could have like tf vars to define my variables, but you'll see why I don't do that in just a second. I do also have some Terraform state stuff in here because I spun this up earlier. We will see how that goes. I spun it up earlier in a different project, but my Cloud Shell is shared, it seems like.
Okay. Yeah, it's ephemeral, and it's I don't fully understand when it's going to have the same resources and when it won't.
Yeah.
But yeah.
So we'll see how this goes. But I was just alluding to why I don't have a TF-vars file. I'm instead just using environment variables for my variables. So there's a format you can use for environment variables, this TF_var_ the variable name. And so I'm using that to set up my project ID and my project number, which you can also see here in the console. So I could copy and paste those in, but I have gcloud CLI commands to just grab those for me. So I'm going to run these to set up my project environment variables.
Okay, so as long as there are environment variables that match the TF, they're prefixed with TF_var, then Terraform will know to pick them up. And then is it your project that's listening for the project ID and project number specifically?
Is it my project that's listening for those, or
like, yeah, in the Terraform we have like we're expecting the project ID and project number variables. Is that what I'm?
Yes, that's right. And this also wouldn't have worked if I didn't already have my gcloud CLI in this Cloud Shell set up for the correct project.
Okay.
So it should be correct here. I could actually check that if I echo $ one of these two, usually this one. We'll make sure, yep, code live 1. So I'm in the right project. Those variables should have been set correctly, so we can move on to our next step. So this one's a bit of a weird one, and it's kind of hacky, honestly. There are better ways to do this, but they are more complicated, and so I haven't implemented them yet. So the issue here is there's a couple of places in my YAML files, which I'm going to use later to deploy my applications onto Kubernetes. And you can't use variables in those YAML files. YAML apparently doesn't really support having just like pulling environment variables from your shell. So instead, I have placeholder text, which is square brackets with project ID. And I'm going to replace that just using the Linux tool sed.
So, yeah, I feel like that's not even, I wouldn't qualify that as hacky. Like that's kind of what I love about ops work. I feel like little like bumps in the road like that between the millions of markup languages are the reason why so many of the ops engineers that I've worked with are like the smartest people I've ever worked with, because you have to solve all these different problems that are an inch deep in 10 different areas. So that's the fun of working with ops.
Yeah, this is like my CI/CD pipeline, if you want to call it that, which I want to call it that. I don't know if I should call it that, is like half manual and half automated in this. I could have a more automated pipeline where it could do some of this stuff for me, but yeah, at this level, and I kind of want it to be a little bit more engaged so that folks know exactly what's going on.
Right.
You know?
Yeah, not too much magic.
So it works.
And that's honestly proper prioritization for a project in progress. Like you don't want to do everything gold plated before the whole thing's done, right?
Yeah, even though it's very frustrating for me sometimes.
Yeah.
Also, in case anyone noticed, that those sed commands did fail the first time because I was in the infra directory and I had designed those to be run from like the home directory of the repo. So I went up a level and ran those, and that worked fine. And then I'm going to enable some APIs. Since this is the first time that we've used this project, brand new fresh project for us here, we're going to need some APIs. So we're going to need cloud build, because that's what we're going to use to build our container image. We're going to need artifact registry, because that's where we're going to store our container image. Container.google APIs is for container engine, or GKE, Google Kubernetes Engine. For some reason, it's just container. I find that somewhat confusing sometimes.
Yeah.
We're also going to be using Firestore, as I mentioned, to store our history, and AI platform, because we'll have access both to Gemma running in the GK cluster and Gemini, which is running in Vertex AI. So we need AI platform for that.
Right. Honestly, that kind of tells the story of the whole project almost in order. You have the execution environment you're building it in, the place you're storing the images, and then the runtime GKE, the database to store the responses from Gemini. That's amazing.
I was saying just before this that I'm really sad that I didn't take the time to put together a architecture diagram to show this a little bit more clearly, but there it is right there in that command.
Yeah, there we go.
And it seems like that's taking a minute. It can take a little bit of time to
It happens,
do that.
and especially when you bundle
There it
like
is.
5 up. I think that might be 5 enables in one operation. So that might
Yes,
be
it is.
Yeah.
So that took it a second, but it's done now. So then I'm going to CD back into the infra directory, and we're going to mess around with our Terraform. So I'm going to get that going, and then we'll actually dive into the Terraform and talk about what's in there. Well, we'll see it as we go too, because I'm going to do a Terraform plan so that we can see what it's going to do.
And as always, feel free to ask questions as we go. I always love these streams because I learn more and more about Terraform as we go. I consider myself like functional as an app dev, but I always love working with ops focused advocates because I learn something every time we touch a new project. So I'm going to be asking questions along with you.
Yes, and please do. I love diving into this stuff, especially for folks who haven't seen it before. I find the newbie questions very insightful, so don't hold them back. So the first Terraform command we're going to run here is terraform init. If you haven't encountered Terraform before, Terraform is a tool for managing your infrastructure as code, and it's a very popular one for that. So it has a lot of logic built into it about how you define your infrastructure as code, and how to run that. But depending on which environment you're running in, it needs specific smarts about that environment. So in our case, we need to know about how to run infrastructure in Google Cloud. So we need to use the Google Cloud provider within our Terraform. And so we have that defined in our file, which I'll show you here in a little bit. But since we need to pull in all of that know-how about Google Cloud, we need to run Terraform init so that it goes and gets all of that information about how to run on Google Cloud. So
sounds good.
Run
that
that
sounds
first.
similar to pulling down like the Google Cloud client libraries and running like an npm build or like a Maven compile, and actually getting them in your class path so you can work with them.
I think so. That's my understanding as someone who doesn't do much of that stuff.
Yeah.
So Terraform init doesn't take much time at all. Then the next generally recommended step is to run a Terraform plan. So this is going to give you an idea of what Terraform will do when you run the apply command, but it won't actually apply anything yet. So we're going to run Terraform plan, and it knows what to do because I named my file main.tf, and so it just looks for that automatically. Cool. So it gave us a bunch of output here, and we've got some errors, so we'll have to take a look at that.
Interesting.
Yeah.
But I do actually really like this feature of Terraform plan because it gives me an idea of what I'm actually getting into, especially because 9 times out of 10 when I'm running Terraform, I've run it a few times, I'm trying to debug something, and I've blown away a certain thing, and I want to make sure it's actually replacing the element I'm talking about.
Exactly. Yeah, it's very useful for updates. And one thing I wanted to point out here is that when we actually run all of this stuff for real, we'll use the command terraform apply, which is not terraform create, because it's not just creating something. If you already have something and you're just modifying it, then apply will also do that modification. So important terminology there. Similar in Kubernetes, we also use apply for running declarative manifests.
Makes sense. And I think that all fits into the, like, this is kind of the file you're applying is like the intended state of your resources. So you're trying to like correct what's actually there to meet the expected state. Interesting.
Yeah. So
It's giving us a 403. Is that the right project?
error, reading or editing project service, code live, cloud build. So it's saying that Cloud Resource Manager API has not been used before.
I think that's because it's trying to run it on Code Live 2.
No, it's running it on one. We have a backup, by the way.
Yeah.
Kitchen magic. We have a backup on Code Live 2. But this happened when I did it on Code Live 2 as well. I was hoping that those API settings that I had done earlier would take care of this, but it seems like there's one more API call that I need to add to my README, which is this resource manager one.
Resource manager.
So
I don't actually know what that one does. Is that...
It seems to cover a bunch of things because it comes up here a bunch. Like there's that error. This is the same error, the same Cloud Resource Manager.
Mm-hmm.
This is also Cloud Resource Manager. This is also Cloud Resource Manager.
Okay.
And this
it looks
one,
like it's an IAM thing from what I'm seeing.
Yeah, that's what it seems like to me.
Which makes sense, because you do have to, to authenticate these services properly. A lot of them, it'll create a service account to run a specific service, and you have to add policy bindings for that. So that makes sense. So you need access to that.
And this was just our Terraform plan. We weren't even trying to do anything, but Terraform has already told us that we didn't have something that we needed. So it's doing a good job for us.
Yeah.
I'm just going to click that link to enable it.
I imagine it would need, like, that's some of the smarts that are enabled by the Terraform Google Cloud provider, because that seems very like platform specific. So
enabling this specific API, or
getting the response that's rich enough.
Yeah.
Or maybe it is just a 403 from Google Cloud, but yeah, it seems like a very in-depth, like, click this link, follow this specific enabling path.
I definitely think we would have gotten a different error if we didn't have the provider defined at the top of the file, because then it would have been like, what is any of this? None of this is in my APIs. What are you talking about? So I definitely don't think we would have gotten this error if we didn't have the Google Cloud smarts already in there.
Fair enough.
So I've now enabled that API. So if I run Terraform plan again, hopefully we will get a different result. Let's see. So since I ran this earlier on 2, it's using my Terraform state file, I think. And so it sees that I've done all of this stuff before. So it's talking about replacing things, even though I don't think I actually have them. But it is saying that it's adding all of the things. And, well, it also says that it's destroying all of the things. So it might destroy them. Oh, yeah, it is destroying them in Code Live 2.
Okay, yeah.
So I'm learning things about how Cloud Shell works with all of this today.
Yeah, huh. And it keeps that state. Interesting.
Yeah. I don't really want to destroy those things. I wonder if there's a way that I can tell it to just add them to Code Live 1 and not bother with the stuff that's in Code Live 2.
Yeah. I don't know if I'm interested. Like, it's interesting that Terraform plan would read that TF state, but is there like a flag for it? Like,
I could also move the Terraform state file out of it and be like, hey, pretend this doesn't exist.
Yeah, what if we rename that to like .old and then...
I could do that. I think I'll do that.
Yeah.
It's a little bit tricky, but like I said, work in progress here.
You're watching a sample be refined live and before your eyes.
Yes. So there's already a backup. What do I want to call this that's descriptive? Will it allow me to use numbers? Can I say Code Live 2?
Yeah. And you need
I need the first one first. Yeah. All right, let's try that. And we also want to move the backup file, I think. Just to make sure.
It's probably listening for the backup too.
I'm not sure. It might not call that in. It might just be there for you to manually call in if you need it. But I'm
Yeah,
not gonna
if I
mess
was
around.
if I was designing that CLI, I would probably at least have you opt into using the backup, not just pick it up automatically. But we'll see what they decided to do.
Yeah, so that does that. Let me clear my screen here again so that it's a little bit easier to see, and then we're going to run our Terraform apply or plan. We're not going to apply just yet. Let's see what it thinks it will do. Yeah, so now that I've changed that, it's not seeing the stuff that is in Code Live 2 that we have sitting in the wings in case something goes horribly wrong over here on Code Live 1. And it's ready to create the resources for us, as you can see on Code Live 1.
Totally fair. And
Beautiful learnings already.
so I also, can't you do like can't you pass a flag like -dry run to apply? So wouldn't
I
that,
think you can,
and
yes.
I assume that would be the same as running Terraform plan, but like for some reason, I haven't been running Terraform plan, and I think I should get more into the habit of doing that because I'm often sort of shooting from the hip, and that's not the idea of Terraform. So I like this approach.
Yeah, it is handy to have Terraform plan. Yeah, so let's go ahead and apply, and we can dive into the actual code. Terraform apply. And all I need to do is say yes, because we already set those variables as environment variables earlier.
Sounds good.
Cool.
And yeah, I see a lot of merit in using Terraform, even if you're trying to kind of feel out how a project should go, because it allows you to make it portable. It allows you to bring it from project to project, and have it be repeatable, and come back to it 6 months later and understand what's happening. So yeah, I'm excited to walk through the Terraform itself and see what we learn.
So let's dive into that. I'm going to do it in the GitHub repo, and we will see what we have here. So I'm going to go into the infra folder because I tried to actually make these organized and take a look at our main.tf file. So you can see here at the top is what we were talking about earlier. Required provider for this is the Google provider. I am also using at least version 6.0, honestly, for something that I'm not even using in here because I actually saw it in the output here. So I must still have something left in at least the file that I'm working from here. But I'm working on Secret Manager. So there's Google Cloud Secret Manager for managing secrets, and I'm working on implementing that into this code as well. Currently, we just use a Kubernetes secret a little bit later, and Kubernetes secrets are not very secret. So generally, the community recommends that you use some other vault solution, like Google Cloud Secret Manager. So I've been working on that, but I haven't gotten it fully implemented yet. So we're not going to be going over that. But
that is interesting. I had heard that it's recommended to use an external secret manager, but I didn't actually know why. Is it like it's just vulnerable to an intrusion? It's not like super non-secret, but it's just less secure than other options.
yeah, the secrets in Kubernetes, I can't remember the exact wording that folks use, but they're more obfuscated than actually encrypted.
Oh, okay. So it's hard to get to, but not fully secure. Interesting.
Yeah. And then I think there's also some concerns about at rest versus in use. So it's not the most secure solution for your secrets.
Fair enough. And on line 6 there, I had also, I haven't seen another markup language or another like package manager using that format for like at least 6 like that. I would have expected, I don't know. That's just a new format for me, so that's always thrown me off. But never took the time to look it up, so it's good to know that that's what that's referring to.
And what I was mentioning there with the version is that for Secret Manager stuff, I need at least version 6 of this, so that's why that's a 6. But yeah, that is a good point that this is at least version 6.
Good to know.
Cool. So that's the provider information, so where it gets all of what it needs to know about running on Google Cloud. Then we've got a couple of variables. Like I mentioned, we're pulling these from the environment variables. So there's no default defined here, but it's finding them because of that special environment variable format that we used.
The prefix. And then we didn't supply a region, so we're just falling back on the default there?
Exactly.
Fair enough.
Yep. Cool. And then we start defining some resources. So first off, we're basically just saying we're going to be using Cloud Build, we're going to be using Artifact Registry, the Container API, Firestore, and Vertex AI. Yeah. So all of these, I think, are why we got those nice errors that told us that we needed some more APIs defined, because it was like, I'm going to be needing these. Let me go off and check that they're enabled. And then it gave me that error that we needed an additional API in order to enable these ones.
That makes a lot of sense. And about the Vertex one on line 51, we are deploying an open model which won't rely on Vertex, correct? Or then we'll also be we'll be calling on a secondary model in Vertex. Is that how it's going to work?
Correct. Yep. That's right.
Sounds good.
So an additional variable here, just the name of the cluster, we're setting that by default, and we use that in other places in this repo. So I'm just relying on the default here. If you changed it, good luck to you finding all of the places where I define that.
That's the Black Diamond Trail if you want to take the harder path on following this sample eventually when it comes out.
Yeah. And GKE Autopilot cluster is what we're going to be using. This makes it so much easier when you're doing little demo exploration stuff, because I don't have to create a giant cluster or look into like the different VM sizes that are available on Google Cloud, or worry about any of that stuff. I just say, I want a GKE cluster to run this stuff on. Make sure that it exists, and you can scale it up to the size that I need for this.
Yeah.
So,
and I like that approach because it allows you to, like, when, as referring to Callum's question from earlier, when you decide that you do have a specific, I need this VM to be larger, that kind of decision needs to be made. It's just changing a param instead of deploying to a whole new compute model, because you've already given yourself room to make that decision later on.
Yeah, or to let GKE make that decision for you.
True, yeah.
In my case, I also have resource requests and limits set in my workloads that I'm deploying onto Kubernetes, and that's what it uses to decide how big of a cluster you need. You'll also see it later when I deploy onto the Kubernetes cluster. It'll take it a few minutes because it's taking a look at what workload you want to create, and it's saying, I don't have enough resources for that right now. And then it has to spin up new compute resources in order to do those. So it takes a little bit longer, but it does it itself. So that's nice.
Neat.
Cool. And so there's nothing particularly exciting here, just enable autopilot. So you'd use the same thing if you were going to create a standard mode cluster where you define all of the nodes and everything, but you'd have to define all of your node pools and everything in here, which I don't need to do because I just have enable autopilot.
Very convenient for us.
Mm-hmm. And then I have additional resources, creating a database in Firestore. So I'm naming it just default. And then I'm creating an initial document in that database. And then I also have a repo that I'm going to need later. So the actual name of the repository is chat app repo, but Terraform calls it my repo, but should work just fine. One thing I do want to point out here is that for these Firestore ones, I have depends on project service Firestore. So we need to make sure that we have that API enabled in order to create the database. And in order to create the document, we need to make sure that we have the database. So we have Firestore database.database.
Very
That's
cool.
what it depends on.
You can lay out all your dependencies like that. Another benefit of,
Terraform.
Very cool.
Yeah, so that's a look at the Terraform. We're over 7.5 minutes in. This shouldn't be too much longer on the cluster.
I do actually have a couple more questions about the Terraform there. So
yeah, so let's talk about them.
It may be in the README. I may have just missed it. But we're assuming everybody's familiar with Firestore. Document store, I'm assuming we're storing our chat requests and responses in there.
Yes, actually in my README, good catch, I do have an example of what those logs are going to look like down at the very end. So here's an example of what the log in Firestore will look like. I think I've actually updated it since I took this screenshot slightly. So I did have year, month, day, session, and then a unique identifier. I believe I also added the hour, minute, second.
Okay.
So arguably, I wouldn't necessarily need the unique identifier if I'm not expecting to get a whole lot of traffic on the site where people might interact with it at exactly the same time. But I still have that unique identifier there just to make sure.
I think that's good to have, yeah, because it's feasible that you'd get multiple requests within a second, and then even nanosecond, microsecond, you might get multiple requests. So, yeah, probably a good idea to have the unique IDs in there.
Future proof.
Yeah. And then I see you're storing the model name of the responding model.
Yep.
Interesting.
So I mentioned earlier we are going to be interacting with two different models. So you can see here in our history, I asked Gemma 29B IT who Cher was, and then I asked Gemini what her biggest hit songs were. And Gemini knew who I was talking about because it had the history from Gemma, even though Gemini wasn't the first one that answered it. It was still a continuing conversation across the two different models.
Okay, interesting. And so you can, I guess that's facilitated by like both models. You'll be sending in the request that includes the chat history, I assume.
Yep.
So yeah, it's all just text. You can understand, oh, I'm in the middle of a conversation. This is what's been said so far. This is how I want to respond, regardless of the model. That makes sense.
Exactly. It's just a fresh interaction with the model every time that just has all of the context in that request.
And that's another step of actually like being able to get your hands on a like continuous chat history example that kind of demystifies it. It's not some much more complex concept. It's just more context put into a reasonable, very understandable request.
Yeah, that was really difficult for me to understand when I was doing this. I was like, okay, I know I want it to have history, but like, what should that look like?
Yeah.
And Gradio has some opinions about it, and the internet has some opinions about it. And I was like, how do I implement this with what I have? So this is what I ended up with.
That sounds, yeah. I feel like there's a lot of right ways to do it. And in the bottom line, like these models are very good at understanding text in a way that makes sense to you. So if all else fails, you can just kind of format it in a way that you'd explain to another developer, and you'll get a pretty good response from the models you're dealing with.
That was difficult for me to wrap my head around at first because I was like, what is the template, the format that I need to use to send this history to my models? And the internet was like, it'll just get it.
Opinions.
Yeah. So as long as it can kind of tell. And then it does have the time and date stamps here for when each interaction occurred and when the session started. And then, of course, that's in the session document name as well.
Fair enough. All right.
Yeah. So this, it finished, but there was an error with my Firestore stuff.
All right.
I think that one thing I saw earlier in the output here was that it had secret manager stuff in it. So I think I'm actually not using the latest version of my main.tf file.
Okay.
So it may not have created the database. So let's take a look at what I'm actually using here.
Yeah.
So I do have the database definition here, but I didn't have the depends on earlier today. And I hadn't updated this apparently with the depends on. So it probably actually created the database, but then it tried to create the initial document too fast. So let's see if that's the case. Let's go over to Firestore.
Fair enough. And I like that it,
there it is.
Okay. So it does try and create as much of it as it can. And if it fails, it doesn't back it all out. It doesn't like fail the whole transaction. So.
And now that we've seen that database does actually exist, I'm pretty sure it just tried to do this too fast. So if we run our Terraform apply again, it should just do it. Yeah. You could plan this first just to make sure that that's all it's going to do.
And it should see, 90% of it is created. I'm just going to try creating the remaining services.
Exactly. Yep. See, 1 to add, nothing to change, nothing to destroy. It's just going to retry creating that.
Coincidentally, it is actually 90% that was created already. And the last.
Oh, yeah, because it's 10 things.
Yeah.
Good point. So that should take no time at all. There we go. We should have our initial document just for good measure. So if we go in here, we can see chat sessions initialize is our only document.
Very cool. a new inbox, mint condition chat app just made live on stream.
Well, the chat app itself isn't even running yet. This is just the infrastructure for it.
Right, so we're in the infra folder, and then we have the whole build pipeline that we have to work
Exactly.
build through.
So let's talk about build steps.
Yeah.
This is where I feel that I have the most work to do in this application, as far as the deployment steps. But we're going to also talk about the application itself a little bit later. Since applications are not really my strong suit, I'm looking forward to getting your opinions and exploring it with you if we have time. So we have all of the Terraform stuff done. Now that Terraform has finished its stuff, we have a cluster to connect to, which we are going to need to connect to. So we're going to do that next.
Fair enough.
We're going to use just a gcloud command. We just need our project ID. We already know what the name of the cluster is because we use the default. So we just connect to our cluster. So now if I run kubectl get nodes, I should just see that it shouldn't find any resources because it's an autopilot cluster, but it said no resources found, not like I failed to make that request or something. So it's connected to a Kubernetes cluster. It should be connected to the right one.
Correctly detecting that there's nothing deployed on the cluster.
Yeah, so let's fix that.
Yeah.
Let's see. Our next step is to set up our Hugging Face token because we're going to deploy Gemma into our cluster. So in order to get the container image, in order to deploy Gemma, you need to pull that from some repository somewhere, and Hugging Face has that. So that's where we're pulling it from. So I already set this up.
Hugging Face is like it's a lot of things, but it's like it's a great place to learn about models, kind of compare them and see the capabilities. It's got nice, concise explanations of them, and it also hosts versions of them that you can kind of pull down and deploy to your target environment. So yeah, nifty tool, very widely accepted. Not a Google thing, but very, very useful to know about.
Yeah. And you can find a whole bunch of different models there. So if you wanted to deploy a different one, then you can do that in a very similar way here. I already set up my Hugging Face token also as an environment variable so that hopefully I will not show it off to everyone publicly.
Yeah, that also wouldn't be very secret.
So. That would not be very secret. Yeah. This part is also not going to be the most secret that it could be, but it'll be fine for our use cases today. So I'm going to use kubectl create, which is also not generally how you use Kubernetes because you generally want to have like a YAML file that defines what you're creating. But if I did that, then I would have had to have my secret in it, and I didn't want to do that. So we're going to imperatively create our secret from literal, our Hugging Face token.
Makes sense.
Environment variable. So we're going to do that real quick. There we go. That's created. And now I'm going to deploy our Gemma 2.9b IT model onto our cluster. So kubectl apply -f and my YAML file that defines how to do that. And there you go. Boom. Created. So now if I run kubectl get deploy, we'll see that it's working on spinning up our Gemma deployment.
Yeah, and I feel like connection to cluster is another area where every ops person that I've worked with does it differently. And I did it very differently when I was out of Google compared to when I came to Google. There are all kinds of tools to do it, and I learned about some that made it much easier that I wish I had known about years ago. Like, for example, my tool of choice before coming to Google was K9s. I always used that to connect to my clusters, and it worked fine. If I was in an environment that was more resource constrained or tighter about what I could use, then I would just go with kubectl, and that'd be fine. But I had learned about tools like Scaffold that actually made it much easier to build iteratively. So that's a whole other area that it'd be great to talk in length about in another stream. But
and it's going to come into play here in just a couple minutes when we use Scaffold.
Oh yeah, we are using Scaffold here. Okay.
Yeah. So for this one, if you go to Hugging Face and try to deploy Gemma, there's like a drop down of where do you want to deploy this model, and Google Cloud is one of the options, and GKE specifically is one of the options. So if you click that, it'll take you to a wizard within Google Cloud that's like, here's what I'm going to deploy for you. So I just copied that YAML file and reused it.
Perfect. I didn't even know that was a feature. That is awesome.
It's really nice. Cool. So that's deploying. We could actually check on it. I like to actually navigate here through the hamburger menu.
That is fair.
So you can see here it has this does not have minimum availability. That just means that it's an autopilot cluster and it's still working on spinning it up. So
Okay.
don't worry about that.
And when we're talking about these models, like, I guess they seem kind of like a black box, but if you watch the logs, it really just looks like a Python app with a web server spinning up. And depending on the size of the model, that's kind of how big it'll be and how long it'll take. I don't actually know how big this model is. I guess we could get some insight into that by looking into the YAML, but
It's unschedulable because
uh,
we don't have any nodes. Yes. So we don't have any data yet on like how much CPU or memory this thing is using, but once it comes up, we will.
fair enough. Yeah, it always seemed like there's got to be more going on, but it really is just like a data-driven application that is ready to respond to requests and give language-based responses. And the closer you get to this feeling like an application, I feel like the easier it is to work with it in other settings when you're trying to like put the responses of this service into a larger service. So
yeah. And so I'm going to go ahead and move on to deploying our chat application because I want to get that going because it takes a few minutes. And then we can dive into some of the code that's going on here.
Sounds good.
So we created our secret. We applied our Gemma model, and that's spinning up. And next, we're going to build and run our actual application, and it's just a scaffold command.
Okay, interesting. And if you had to describe scaffold briefly, how would you go about that?
Let's see. I looked it up earlier today. Can I actually remember how they described it? I see it as, I think they described it on the website as a pipeline definition tool, kind of like Terraform is for infrastructure as code. This is for the pipeline of how your application gets deployed.
Interesting. Yeah, that makes sense to me. I feel like it. Yeah, it does all the legwork of me like changing a Kubernetes config to like actually putting it into my cluster and showing me what it looks like. So it lets me iterate on the deployment on Kubernetes in like a local environment, which is cool.
And this failed. I have a sneaking suspicion that my files are still set up for CodeLive 2.
Could be.
So let's check that out. CD app. No, actually, we don't want our app code. We'll look at that in a minute. But we want our build files. Yeah. We want specifically chat deploy and scaffold.yaml. Yep. So you see right there. So because I had not actually updated my repo with the code that is in GitHub, unfortunately, I should have thought about doing this earlier.
That is okay. Are you a fan of the vim find and replace command?
Yeah. I haven't done that in a bit, though.
There's only one, though. So that.
Yeah, there's only one in this file.
Fair enough.
There's two in the other one, but they're also super easy to get to. Yeah. VI scaffold is the other one.
You say you haven't done it in a while. I absolutely have to look it up every time. I never remember these vim commands. I think it's
S thing that you want to replace, that you're replacing it with, and then G.
Yeah, I think that if you want to do it global, yeah. Otherwise, it does it in the line. Yeah, and it's.
I didn't need to replace that much.
I always forget commands like that and how to show line numbers, but.
Yeah, but these are easy enough to just kind of do there. So, yeah, if I had properly pulled my Git repo before we had gotten started, we wouldn't have had this problem. But
fair enough.
That's fine. Gives you a chance to see what happens when things go wrong.
We're also demonstrating error messages.
Yes.
This is an important part of building with Google Cloud. Understanding error messages in general is an important part of building
any kind of technical career. And so now we're going to run our scaffold build. So you can see it kicking off here. It's looking good. So this is going to go out to cloud build and build my application. I have a cloud build.yaml file in here as well that defines how I want cloud build to do that. Then once it has the image, it's going to put that into artifact registry. And then it's going to go ahead and run that artifact that it created on our GKE cluster. So it kind of takes care of a lot of the steps of deploying the application for us.
Sounds good.
It was kind of messy to do all of that stuff by hand. So thank you, Scaffold.
Yeah. And I imagine I haven't done a lot of deploying models, but I know that, at some point you actually have to move the model around, and that these models are often a few gigabytes big, depending on the size of the model, depending on how many parameters are being used or the specs of the model. You're going to be downloading and starting up an application that's a few gigabytes in size. And so I'm imagining the build pipeline will slow down at some point. We'll see if that's true. We'll see if it happens or where. But that's also another thing that Hugging Face can show you if you go onto their. They have nice little model cards, and they will actually show you kind of the files involved with the model you're pulling down, which I think is neat.
And you can see that our Gemma deployment is okay now.
All right.
Eventually it got availability, but you can see the other one does not have minimum availability because it's an autopilot cluster and it's spinning up resources.
Right.
So we could dive into some of the build code, or we can talk about what the next step will be, workload identity, real quick.
I think maybe a quick peek at the build code would be cool.
Cool. We'll come back to workload identity in a bit then.
Yeah, I think
Don't you all worry. All right, so let's take a look in our build directory. So in here we have a Docker file. We have chatdeploy.yaml, which deploys the chat application. We have cloudbuild.yaml, which defines how we build our chat application image with that Docker file. So this Docker file is also for the chat application. The Gemma one's just pulling the image from Hugging Face, so we don't need the Docker file or cloud build. So we have that YAML file, and then we have the scaffold, which defines everything. What do you want to look at first?
Let's go top to bottom. So Docker file first. And
all right.
Yeah, seems it's often deceptively simple. Just need Python and then the model ID and the port it's going to be running on. Yeah. It often just feels like a web service. I'm assuming it'll be running like GUnicorn to take requests on that port. And
actually, I should update this Docker file and just remove all of these environment variables. I've since updated my code and it doesn't use these anymore.
Okay.
But I originally based it off of a demo application made by one of our colleagues, Gary Singh. And his implementation of this chat application used environment variables to decide which model it was interacting with. And you could use a variety of different ones, not just Gemma or Gemini. You could define them in your environment variables and it would figure it out. But I have changed the code and it doesn't actually work that way anymore. So I should just remove those.
Well, good to know. And then the chat deploy YAML, we did just deploy this, right?
Yes.
We look at the...
So this is what we just ran, and we had to fix. So this is what it should have looked like instead of having code live too. It should have just had project ID in there as a placeholder.
Right. Okay.
You can also see in here that I have requests and limits set. These are based on me running this a bunch of times and seeing how much it generally tends to use.
Fair enough. Yeah, that's off. I feel like that's often the way it goes. And I've always found the units used when defining resources in Kubernetes to be interesting. Because isn't there a difference between MB and MI? It's on the margins of the rounding of the units between megabytes and mebibytes and
mebibytes.
Yeah, it's a strange little world of standards curation. But
agreed. And I think it may also be environment specific whether you use those or not.
I didn't know that. Okay.
I don't know. Just a theory. I haven't looked into that deeply, but possibly. Because I know in the cloud, mebibytes and vCPUs and stuff, we use slightly different units sometimes than you would see in other environments.
Oh, I see. And then, okay, so we have our Gradio Chat, an app named Gradio Chat, and then we have another service. That's the service for it, Gradio
Yep.
Chat.
So that's how we're going to interact with it. Oh, yeah, it does that. And so it's type load balancer. So that means that we're going to be able to interact with this application on the public internet via a Google Cloud load balancer. So this actually, another fun fact with cloud provider code. So in Terraform, you need to specify which provider you're using so that Terraform knows how to do that. In Kubernetes, you actually need to do the same thing. There is cloud provider specific code or environment specific code, depending on what kind of hardware you're working with, that is not in Kubernetes itself anymore. It used to be. But just this year, we finally got rid of all of the environment specific code from Kubernetes. It was over 1 million lines of code removed, and the community is very proud of it.
Wow. So was that just a separation of concern? It wasn't like necessarily the container orchestration platform's concern which environment you're running it in?
It's partially that. It's if all of that code is in Kubernetes itself, then all of that code has to adhere to Kubernetes release processes. So even if something big changed in the cloud provider, you're not going to get that change until Kubernetes updates.
Ah, that's fair.
If the people maintaining that cloud provider code were tied in enough to the Kubernetes release processes to actually get it in the following release. So there were a lot of coordination issues with that.
That's fair. You don't want to have a collision of release trains like that. That makes a lot of sense.
And if you have all of this code in Kubernetes itself for the different environments, but you're just running at home on your Raspberry Pi, your Kubernetes doesn't need to know how to run on Google Cloud and Azure and AWS and every other type of environment under the sun. You just need the one that you have. No need to bloat Kubernetes itself with stuff you don't need. So separating it out allows for that. But since we're using GKE, GKE takes care of making sure that it has the cloud provider specific know-how available to you pre-installed on the cluster. Generally, that stuff is handled through custom resource definitions these days. I'm not sure exactly how it's implemented in GKE. But if you were running this on like virtual machines in Google Cloud instead of on GKE, you'd need to figure that out and set that up for yourself.
Interesting. Okay. Okay, and then we have a service account, which we're using on line 28, I guess. And
Yep.
so we've defined kind of like what the app is, what port it'll run on, how big it'll be, and then very importantly, the service account will give it access to the actual resources depending on what permissions we've given that account.
Exactly, which we'll talk about in workload identity.
Yeah, very cool. And do we have any other files in this? I think we have a few more in this folder.
Yes. So next is cloud build.
Mm-hmm. And so I've had people get confused about like, why do I need all these different build files in order to deploy on cloud build? And you don't strictly need all of them in all cases, but cloud build.yaml is one of the options to tell cloud build what steps to take in deploying your application. In certain contexts, like if you're deploying from source code or you're just deploying a specific image, you can skip having a cloud build, but I like this because it makes it a lot more explicit. And so what are we actually doing in this?
I'm a big fan of making all of the steps explicit, as you've seen in this entire thing. So the basics here, we are running a build, and we're going to put the result of that build into, we're going to call it first, I guess, this whole thing, which defines a whole bunch of different pieces of what's going on with this build and where it's going to be stored.
Mm-hmm.
And it's going to be using the Docker image format. So there's a couple of things in here that say Docker. This is Docker. This is Docker.
Yeah, and this may look a little bit like hard to digest, but really, I feel like if you've worked with Docker, this is something you can pick apart because the cloud builders are kind of like a toolkit of tools you can use. Cloud builder is just an execution environment. It's like having a build server that you don't have to manage the resources of. And so on line 16, we're saying on our build server, we want to run Docker with the arguments build, the T flag. So we're trying to tag the image and we're trying to say, this is where we want to put it. The source is right where we are. And then we're passing the Docker build kit. I don't know if that enables it, that flag.
I think it just enables it. Yeah.
Yeah. So it's kind of like you have to feed regular Docker commands into an environment where you don't know which machine is exactly going to be running it. So you have to use these abstract builders that will be there when you need them. Very cool concept.
You probably know more about Cloud Build than I do.
Right?
I
Yeah,
just
and
knew I needed to use it because I didn't have Docker installed on my local machine. So I needed some way to build this without that.
totally fair.
Plus, makes it more accessible for folks. If you're running it Google Cloud, you should have access to Cloud Build.
Absolutely.
And I am using bad practices here, not best practices, of using latest.
Fair enough. Well, we can't pin down every version. Not on the first cut.
Yeah. It's one of those things that I'm doing to make the manual steps like more spread out so that we can talk about them in the README. If I were to put this all together into a more automated pipeline, then I could also automate it so that it's giving everything more reasonable names. But this works so that I can build it and rebuild it and do my development cycle and get the new build of the application each time.
Easy way to do it, and it's also a lot better to just have a simple build pipeline than to do things yourself, because I'll forget. Every time I come back to a project, I forget how exactly I was building it. I hope it's in my shell history. It's not. It's a mess. So
And
it's better.
it's nice that this doesn't overwrite everything.
Yeah.
Like, I will still have all of the old images that I built of this application. They'll be in the history of Cloud Build. So I can go back to them if I need to. They're just not helpfully labeled.
Fair enough.
And I have done it.
All right, interesting. And I'm very curious about this Gemma 2B9B deploy YAML.
Yeah, so I didn't actually write any of this myself. Like I said, I just copied it from what it automatically does when you try to deploy from Hugging Face.
Yeah, interesting. So Hugging Face has prepared this this wizard YAML to deploy to GKE. And so, okay, yeah, it prepares a server. We have the inference server, which is running Ubuntu.
And it's getting it from our model garden.
Very cool. Okay, so it's from Vertex. It's pulling the Gemma model from Vertex, I guess, and then running Python 3.10 at the end of line 22. And there we go. That's what I was looking to see at some point. On line 26, we see that we're going to be using 5. Is that 5 gigs or is that 5, 8? Maybe we can zoom in a little bit.
Oh, this one?
Yeah.
58.
58 gigs of memory. And
just a little bit.
And 120 gigs of ephemeral storage. Interesting. So not the lightest weight server, but
that's its request. It doesn't necessarily have to use this much, and it's also the same as its limit. So this is saying this is the max that I would possibly use.
Thank you for pointing that out, because I'm like, that's huge. That makes a lot more sense. Okay.
Yeah, I should probably set that request more reasonably.
Hey, but I feel like I can see why they would set it that high for a wizard. You want it to work, not to be super efficient on the first pass.
And also, you can set up things in Kubernetes, not just GKE. Well, vertical pod autoscaler is kind of implemented to work very well in GKE, but it is an open source concept, so it should work in some other contexts at least. But there's a concept of a vertical pod autoscaler in open source Kubernetes where Kubernetes keeps an eye on your applications and can let you know what you should be setting those requests and limits to. And it can actually do it for you. That has traditionally been very disruptive because it'll have to recreate the pod in order to change those limits. But just with the last release or with this upcoming release, they now have in place vertical pod autoscaling, pod resizing.
And so I thank you for explaining that concept first off. And so like vertical autoscaling is like you're taking the pods that are there and you're making them bigger.
Yes.
Like more resources added to the same running service or the same service, let me say that. And then horizontal would be you're making more of the services.
Exactly.
But then when you say in place, like you can kind of hot update, you can, without having to bring the service down, increase the resources to that pod and it can serve more requests. That's very cool.
Yeah. New thing in open source Kubernetes. Check that out. It'll definitely work in GKE.
Okay.
So keep an eye out for those release notes to understand more about exactly how that works if you're interested in it, as I am right now, as you can see.
Yeah.
And I do want to call out, we were looking at this one. I was getting distracted by it because I'm like, wait, but the model garden, we're actually pulling our image for the container from Hugging Face, which is why we need our Hugging Face token.
Right.
But this is a label.
Oh.
So it tells the system some information about the model that might be used in other ways. But it's just a label. It's just text. It's not actually doing anything itself.
Good to know. Good to know. Okay. And then we have a bunch of environment variables that don't seem to matter to us. CUDA memory would be for parallel processing. Not our concern. The model works. I'm confident in that. But yeah, very cool to know. And then you have your Hugging Face token.
Yep. Which we're pulling from our secret. It's pretty easy to implement this to just be like, hey, the token's in a secret. When you're spinning this up, just go grab it. So that's why we're doing it that way.
Very, very cool. Yeah. And that kind of like, that satisfies my curiosity about what exactly we're deploying when we deploy the model. We're saying, here's a big old inference server with a whole bunch of as much memory as we can request, essentially. And
importantly, we do have a node selector here saying we want NVIDIA L4 compute GPUs available in our cluster for this. So Autopilot takes that node selector and goes and finds us the resources that we need, rather than us having to say explicitly, use this size of Google Cloud machine and do all that.
Very cool. We just say we need this one accelerator, and then it says, I'll find you the appropriate machine family for that.
Yes.
Very interesting. Yeah, and then we have that's the important part when I'm kind of, like, my understanding of Kubernetes is like, I need, when I need something to communicate externally, I need to have a service, usually a load balancer, but for internal communication, that would be the name and cluster IP would be using. So it'll be on an 8000, target port 8080. Cool.
So I want to call out on this one. This has tripped a lot of folks up who I have seen try to do what I'm doing here. When you deploy Gemma onto GKE by default through that wizard, it's going to deploy it as a cluster IP type service, which is the right thing to do, I would say. It is the best practice. That means that the Gemma inference server is only going to be accessible to other things running within the Kubernetes cluster.
Internally. Yes.
And so that was troublesome for developing my chat application.
that is the secure default. But yeah, like when you're deploying a Cloud Run service, you want to accept external invocations or unauthorized invocations unless you want to set up authentication for your first test request. So yeah, that makes a lot of sense.
Yeah, so Vertex is convenient here because it'll spin up Gemma or Gemini, whichever model you're running in Vertex, and then it'll give you an endpoint which you can reference from wherever you're actually running your application. But in this case, we're going to be running all of our stuff on our GKE cluster where we can control everything. And so it just needs to talk within the Kubernetes cluster, which is a more it's a different security profile from the endpoint. The endpoint has different ways that it makes sure that whoever it's interacting with is the right thing. But this is kind of simpler in that it's just, if it's within the cluster, it's okay.
It's safe. Fair enough.
Well, you can also put additional restrictions on there, like having MTLS between those connections and things like that. There are ways you can implement additional checks so that not anything on the cluster can interact with this. But at least only things on the cluster will be able to interact with it.
It's a pretty good gate to start with. Okay.
Yeah.
Fair enough. All right, and then I think we have one more file in the build folder.
Which is scaffold.
Yeah, perfect. And that one's pretty short. So we're just saying this is the repo that we want to push our artifacts to. So when we make a change, scaffold will kind of listen for us, I'm assuming, and then say, oh yeah, you've made a change to this build file. Great, I'm going to build it and deploy it to that repo for you.
Yep, you can run it in dev mode where it also like picks up on those changes and makes a new build for you automatically.
Yeah.
But the way that we ran it is just, hey, go run the thing. Fair and enough. Let it go.
Okay, you're using scaffold much more in like a declarative, like I'm explicitly asking you to go and run this, rather than like listen to this folder for changes and go for it.
Yes.
Makes sense.
You can do both of those though with this same file.
Very, very cool.
Depending on how you invoke scaffold.
Okay, well, now that we understand every line that we just deployed. Um, what what are we looking like? What's actually,
What have we got? Let's see here.
or do you want to go through workload identity and understand how this is authenticated before we do?
Well, we won't be able to actually interact with the chat app until we do that.
Fair enough.
It looks like we are still waiting for minimum availability on the chat app, but as far as Scaffold is concerned, it looks like it's done.
Okay.
And it doesn't look like it had any errors. So I
Great.
believe we are just waiting for availability on the autopilot cluster.
Mm-hmm.
We do have a crash loop back off, but that's probably just because of the minimum availability. It's like trying to use resources that aren't there.
And yeah, if it's looped and backed off far enough, it might be waiting like minutes between retries. So,
or it might be doing that actually because we haven't implemented workload identity yet, and it's trying to use something within Google Cloud, and it's failing.
might be getting 403s. Good point.
Yeah. We could actually look at that, or we could just go ahead and do the workload identity steps because we need to do those anyway.
Yeah, why don't we do the steps and then take a look?
Yes. So let's talk about workload identity. So we mentioned the Gemma workload that we're running on our cluster can only talk with things that are within the cluster. Workload identity is how you enable something that's in a GKE cluster to interact with other things in Google Cloud. It gives it an identity that can be used to authenticate with other services.
Very cool. And I think this is a cool feature. I understand some of it. Is this a Kubernetes feature or a GKE feature?
I would say it's a GKE feature. Any cloud provider will have a similar concept.
Similar concept. So it's using similar like Kubernetes providers for security, but workload identity is our implementation.
Yes, that's how we refer to our implementation of giving something an identity.
Good to keep that straight.
Another way to think about it is we saw earlier that we have that Kubernetes service account defined in our deployment YAML. So that is a Kubernetes service account. It's a service account that exists within the cluster scope. It has nothing to do with Google Cloud. The outside world knows nothing about it. It's just other things within the Kubernetes cluster could use that service account to authenticate with each other. So like I said, only things within the cluster could interact with Gemma, but you could put additional restrictions on that, of course. And Kubernetes service accounts would be one way that you could do that.
Okay.
But that doesn't give us the ability to talk with anything else in Google Cloud. So we need the Google Cloud concept of workload identity. The way that this used to work, and it doesn't work anymore this way, there's a simpler way now, is you would need a Google Cloud service account, and then you match your Kubernetes service account to a Google Cloud service account. And so then your Kubernetes service account essentially kind of has this pass through to a Google Cloud service account, which allows you to interact with services. That was the harder way. I tried implementing this that way at first because that was how I first learned it. And then I learned that they really did recently make that easier.
That does sound harder. So yeah.
So the way that it works now is you just directly say, here's my Kubernetes service account, give it the permissions that it needs. It acts as the Google Cloud service account as well. So you set it as the principal. So you can see here, the member that we're assigning this role to in this gcloud command is a principal with this long string that's got your project number in it. It's got where you are, information about workload identity pools, all of this stuff. But the important thing is right here at the end. Within our Kubernetes cluster, in the default namespace, we have a service account called Gradio KSA, our Gradio Kubernetes service account. And that's what we're giving this permission to.
Very cool. So we had, that makes sense. So rather than having to have an external service account that this talks to, we just had Terraform create our one Kubernetes service account. And then
Kubernetes YAML created that one Kubernetes service account.
Kubernetes YAML, we created that one service account. And then we have to run the gcloud command to add the policy binding to give that account permissions.
Yes. We could actually run this in Terraform, but we didn't have the Kubernetes service account created yet because Terraform created the GKE cluster, and then we had to run the application on it and create the resources on the Kubernetes cluster before we could give those things permissions.
Right. That makes sense.
So now that these exist, this should work. Yes. I did try this earlier running it before the thing existed, and that did not work, which is reasonable.
Yeah. And so by the thing, we mean like a build of the application, right?
What was I talking about?
You said we don't want to run these gcloud commands until the thing exists.
Yes, until the Kubernetes service account exists.
Kubernetes service account is okay, created. Yeah, makes sense.
Yes. Earlier today, I tried running it before I had created the Kubernetes service account, and it failed, being like, there's no thing called that.
Very reasonable. Very reasonable.
Yep. So now, I think I've got this one still that I haven't done yet.
And so each of those IAM policy bindings, that sounded like a confusing term for me at first, but we're just saying we want to give these roles to this account. And so which roles are we giving to this KSA?
Yes. So our chat application will have permission to create tokens. It needs this to interact with any other Google Cloud service. It's going to need a token to authenticate with that service. Then it has AI platform user. So that's for Vertex AI for interacting with Gemini. And then it has a data store user. It's just those three. So data store user is for our Firestore database.
Okay, fair enough.
Allows us to write logs and I would say see our history, but actually we don't pull the history from the Firestore. For a single session, Gradio actually carries the history over for us, and I just use Gradio's native concepts to do that rather than pulling from Firestore. But it is all in Firestore, so I could pull it from Firestore instead someday.
Okay, good to know. And yeah, there's a whole lot to be learned about IAM. I am not the expert on IAM, but we do have several advocates that are great at it. I'm actually going to link a blog to learn more about identity access management if you're interested. So that'll be in the chat.
Still does not have minimum availability.
Interesting.
Usually this only takes about 5 minutes. It might be because I didn't have that permission set up. We could take a look at the logs.
I would take a look at the logs.
Yeah, I'm going to also just go ahead and recreate it manually to make sure that it's on its way.
Kind of the fastest way, yeah. And I, crash loop backoff has become one of my, I just tried 88 seconds ago. So it might be on a fairly long step if it's doubling each time. 5 restarts in, yeah. I have seen a whole lot of crash loop backups in my day. And if it's not clear to anybody in the audience, like what's happening there is Kubernetes tried to create a resource, it crashed for some reason, and so it is looping. It's trying that again, but it's following an exponential backoff where it will take a little bit longer to retry each time. So maybe 30 seconds the first time, and then 90 seconds the next time.
There we go. It's up and running.
And now it's up and running.
But we can still look at the logs for what was going wrong. I'm pretty sure it was something to do with those. Yep, there we go. Permissions denied.
You called it. All right.
Yep. I have done this a couple of times at this point.
Yeah.
Cool. So that should be up and running now. It does take Gradio a little bit to get the app running, though. So I'm going to go ahead and bring that up, but it'll take it a few minutes, and we could take a look at the app code.
Yeah, I think that'd be great.
And also make sure that I'm not forgetting any steps. So this is just going to sit here for a while.
Fair enough. Yeah, maybe we take a look at the app code. I did want to point out when I kind of fought the urge when we were going at the start, but the interface that Gradio provides is so beautiful.
It's
and
nice.
It's so little input from yourself as the developer. I really encourage people to try it out. Importantly, because it allows you to mess with the parameters, or the hyperparameters of the model, as some people would call it, where you may not need to tinker with them, but being able to have an interface that allows you to send in your request and tweak them as you go, fantastic feature.
Yeah, so you will be much more familiar with this stuff, honestly, than I am. I kind of bumbled my way through this.
Hey, that's the nature of it. We're all here so early that you have to bumble. So
yeah. I was much more excited about setting up the GKE cluster and the pipeline and stuff.
Fair enough. Yeah.
Than doing this part. But I'm at a stage where I could really use some more knowledge about Gradio and frameworks and things. So hopefully we can learn a little bit. Though
Yeah.
we do only have like 10 minutes left in our scheduled time.
Oh boy, yeah, time really flew. But yeah, we are coming towards the end. We'll be able to try it out and answer any questions we go, and then we can dig into some app code stuff.
Yeah.
So
So let's take a quick look overview of the app code at least.
yeah,
So of course we start out with our imports. Not a whole lot interesting there. We've got Gradio being imported, some Google stuff, Vertex, Firestore, datetime, and the UUID. We talked about how those are used already.
yeah, and really, line 17 there is doing an enormous amount of heavy lifting for us by bringing in Gradio and offering almost every aspect of the the application that we need. So we're gonna, when we get to the actual app code on 30, we're pulling in, or 29, we're doing the auth default, which.
So this is pulling in the project ID.
Oh, okay, great.
Yep.
Project ID.
It's a fancy way of doing it in Python that one of our Python developer advocates taught me to do.
Very neat.
Both Leonid and Katie McLaughlin told me about this.
Very, very cool. We have our model ID there. We're serving on port 8000.
These are the same values that we set as environment variables earlier that I probably don't use anymore.
Yeah.
But I've left them in as a reminder because I really liked the way that that was designed at first. So.
And then we're initializing our Vertex client on 42, it seems.
Yep.
Setting our session UUID, generating it randomly, UUID 4, and then formatting our date time string in the document ID for our Firestore collection on 52.
Yep. So that's just setting up a whole bunch of stuff. And then we get to the main event. This is the primary chat function. Every time a user sends a message, Gradio calls this function, which sends the user's input to the appropriate AI, as indicated on the user interface, which we'll get to at the bottom, updates the chat history for future use during the session, and it records the chat history in Firestore.
Very cool. And so we're able to pass in the model name. We'll be using this for both models. And we're actually passing in max tokens for each one too. Interesting. So it's flexible in terms of like how much of a request we're going to accept.
Yeah. Could be different for the different models.
Yeah. And then on 79 and 82, I see the Gemini and Gemma 2B call requests. Very cool.
Yes, here. So we have a different function that we're calling, called Gemma model or called Gemini model, depending on which one they've specified. And before we pass anything to that, we create an aggregated message of the message and its history.
Right. Aggregated message. Okay. Yeah, and that kind of, that's where we're passing in the context of this is the system, this is what's been said, and then this is what you're trying to add to the conversation. That makes sense.
And that's how you can talk with both Gemma and Gemini, flipping between them, and they both know what's going on.
Very cool. Very cool. Yeah, and then we have the actual application, the interaction, and then on 98, we save it, I'm assuming, to Firestore.
Yes. So that's a separate function that does all of that. And then it returns the output.
Very cool.
So we can take a deeper look at how it calls Gemma.
Yeah.
So when we construct a request to send to Gemma, we need to use the right JSON formatting. So we need to send it, of course, the message, but also the model temperature, top P, max tokens, all of the variables.
And I like the way this is built. It's very kind of explicit the way you're building up the JSON here. You're saying, you know, empty dict, and then we start pushing in one parameter at a time. Yeah, makes sense.
And keynote that trips up everyone who tries to do this: if your model is running with TGI, as I believe this one is, which is determined at least partially by whether you're running on GPUs or TPUs in Google Cloud, also by which model you're running and how that is set up to run. It could be either TGI or VLLM, are the two like engines that could be running your model. And those determine the JSON format. So if you're running with TGI, then the message that you send it, the request, goes under the inputs key.
Yep.
But if you're running with VLLM, that's going to be, what is the other one? Requests or something like that?
Requests are, I'm only thinking of the output formats, like predictions.
Yeah, I think it's prediction.
Yeah, okay.
Yeah. But in my case, I'm using TGI, so it's inputs. That's why in those things that we set here, which LLM engine are you using? You
Very
want to be able to switch the JSON format depending on which engine you're using.
neat.
And there are a variety of ways to figure that out with like the labels that we saw earlier on Gemma. I believe there's a label that tells you which one it's using.
And both of these models are using TGI, correct?
So this one is using TGI, but since we're interacting with Gemini through Vertex, I will give you a preview here. It's just a call to Vertex.
Oh, great. Okay, yeah, handles it.
I don't even have to construct all the JSON.
Yeah, that makes sense. And so, yeah, this is kind of the difference between using an open model that we are deploying and passing the requests into ourselves versus like just interfacing with a hosted model. You don't have to do as much of it yourself, and that makes sense.
Yeah.
Fair enough. All right.
We have 5 minutes left.
Yeah, I think I want to hop into if it's deployed. I think
see if it's deployed. There it is. I think it's working. Maybe. We'll see. Yes, there it is.
loading.
That loading symbol tells me that it's there.
Yeah. Do you think we could zoom in a bit?
Yeah, of course. What do you want to ask?
Let's ask. That's a good question. I probably should have thought about that before. Why don't we ask what the difference between TGI and VLLM is?
I would like to know that. Better than I do now, at least. Between TGI and VLLM. And one thing that I left broken in here for us to try and fix, since I am not a UI person, I actually have some images here of like the logos for like GKE and Vertex and stuff. But they're not here. So that's
they're not loading.
Fixed.
Interesting. Take a look. And it gives you a countdown on how long each one of the requests is taking. Really enjoy that. And if we expand the additional inputs while it's processing.
Yes. So you can take a look here. Oh, yay, it responded. Doesn't take it very long usually on that first one. So by default, it's set up to interact with Gemma. So we are interacting right now with the model that we deployed on GKE. So we know that that Gemma model is working. And then we could also switch this to interact with Gemini for our next thing. You can flip back and forth as much as you want, and you can set all of these factors.
Very cool. Yeah. And then, okay, so TGI is for implicit reasoning. Great. Subtle relations between text. Yeah. And then VLLM is for conversational, fine-tuned for conversational applications.
Interesting.
So I think I've seen use cases where you'll reason.
Cut it off.
Oh, okay. I guess we hit the limit.
Noted.
Yeah. Interesting. Okay.
So now I've switched to interacting with Gemini, but we could ask a contextual question like, which one is better? Neither of them are probably better, but...
Yeah.
And you see that came back really fast. We're using Gemini Flash. There's no better.
There's no better. And actually, really quick, could we go to the logs?
Of course. I was hoping you'd ask that.
Yeah.
That's my favorite thing to do, is to interact with them both and then try to look at my logs and see if I can see the differences. I'd have to zoom out on this a little bit.
Fair enough. We've got that big old introducing scheduled backups pop up.
Oh, I can remove that actually. There we go. Yeah, so you can see here is our one session. And so we've got our question, which one is better? And we have Gemini's response. We should also have another one for Gemma, so there might be... Oh, there it is.
Updating, yeah. That makes sense.
Yep, so we have both of them in the same document.
And the timestamps.
Mm-hmm. And you can tell this one was Gemini and that one was Gemma.
So if you needed to restore this chat between two sessions, you could do it no problem.
Yep.
And keep the timestamps intact. Very cool.
And so that's the demo. It only took us an hour and a half.
Interesting. Well,
but we went really in depth.
We did. We actually went through like all the code, which I love doing on these. We had some errors. We had some, interesting hiccups and worked through them. And yeah, I feel like this was a pretty like in-depth and comprehensive walkwood of how to do this. Now, I am left with all kinds of questions like, how would these parameters affect our requests? How would you go about customizing an app like this? And I think we have to leave that for further reading, or for if it's something you're really interested in, feel free to let us know. But yeah, I feel like this is a great primer on like how to deploy something like this on your own in an environment where you can kind of work with it and take it further in the directions that interest you.
There was a lot to unpack there, so hope that you picked up at least a few things.
Yeah. All right.
Thanks so much for joining us today. Thank you for having me, Aaron.
Absolutely. Thanks for joining us again, Caslin. Hopefully, we'll see you again soon. And I'll be keeping an eye out for the sample when it comes out, sharing it with the audience, and encouraging you all to try it out yourselves. But for now, we're going to say goodbye and encourage you to tune in next week, where we'll be exploring another topic with AI and GKE. So, yeah, it's goodbye for me.
Goodbye.
See you next week.